Hi, my name is Phil Liu and I'm with PNSQC, and I just got out of a fantastic keynote, and I happen to have Casey Rosenthal here. And Casey, your talk today was amazing. You know, when I think about all the principles of chaos engineering and intuition engineering and all these different tools that you're using to help Netflix address some of the fluctuations in quality, I was wondering if you could touch on what would you say would be the top thing that we can take home and be able to use in our daily work?
Top thing to take home and use in your daily work. Yeah. I really think chaos engineering is a brand new discipline within computology, within computer science, and the way we designed it, the way we structured it, it's something that you don't have to have the entire weight of a company like Netflix behind you to start implementing those practices. So I'm pretty confident, at least I haven't heard an example to the contrary yet, I'm pretty confident that anybody can start taking chaos experimentation, chaos engineering, empirical practice, and start applying it to whatever software that they have, that they're putting into production.
Okay, so, you know, chaos, I mean, that's a big word, right? So what would that be like? People, I think somebody asked a question.
Start by setting up a very simple experiment.
Right.
This is how my software works. This is how I expect it to work. Finding that steady state to measure your metric of interest, to build your hypothesis, is really key. It's very business dependent. For us, it's how many videos start streaming in a given second.
Okay.
That's our steady state metric. But for others, it might be how many products are purchased per second, or how many transactions happen per minute, or whatever. Figure out what that steady state metric is. Build your hypothesis that steady state will not change. Split your production traffic or sample traffic off into two groups, control group and a variable group, and start doing things in the variable group. And if the steady state continues for both of them, if they can continue to track together, then you have more confidence in your hypothesis. You have more confidence in your distributed system. If they don't, then you've disproved your hypothesis, and you have less confidence that your system will tolerate that kind of effect when it happens.
Right. So I guess the key point really is to get that steady state and define it, and then you can take these little changes and
yes, and it's helpful for things outside of chaos engineering too, to have that one metric that really defines the business value that the software is delivering.
I would imagine that we can apply this in our own personal lives too, and try to figure out what our steady state is, and try to get better.
I'm not sure I know how to split somebody off to do that.
Right.
But yeah, I've heard that there is interest in doing in applying similar practices in everyday behavior.
Great.
I haven't experienced that yet, so I have no idea how that will work.
Well, thanks a lot, Casey.
Thank you.
Have a good conference, and hope to see you.